Radar plotting. The purpose of collision avoidance radar plotting is to assist the watch officer with their situational awareness. This allows he or she to maintain a good decision-making environment. The objectives for the basic triangle: you will be able to construct and label the radar plotting triangle. From this radar plotting triangle, you will be able to determine the direction of relative motion, or DRM, speed of relative motion, or SRM, closest point of approach, or CPA, and the bearing of closest point of approach. Time to closest point of approach, or TCPA, the contact's true course and true speed, or the true motion, and our own ship's responsibility in this triangle if we are in an overtaking, head-on, or crossing situation in accordance with the navigation rules. You will need plotting tools and plotting materials. The plotting tools you can use dividers or a compass or both, navigation triangles, parallel ruler or roller plotter, mechanical pencil, calculator or nautical slide rule. For plotting, we will need a radar transfer plotting sheet or a maneuvering board. For this presentation, we will be using the radar transfer plotting sheet number 5089. You have several choices when you do your radar plotting as far as labeling goes. The ERM triangle and the RTM triangle are both mentioned in the U.S. publication 1310, Radar Navigation and Maneuvering Board Manual. The WOA triangle is used preponderantly in Europe. These are the representative legs of those triangles. In this presentation, I will be using the ERM triangle. If you're plotting directly from a radar or from a radar simulator, the radar should be C-stabilized. This allows for true courses and true speeds which are required for collision avoidance. Your orientation should be north up, and the radar presentation should be in relative motion. For the example I'm going to be using, we will be on a 12-mile range scale. So if you're on a radar or your plotting sheet, each range ring would be 2 miles apart. Our own ship's true course and speed will be 000 degrees at 20 knots, and will be on an observation interval of 6 minutes. So from the time we plot the contact one time, we have to wait 6 minutes to plot them again. The advantage of a 6-minute plot, it is 1/10 of an hour, which facilitates time, speed, distance calculations. At 20 knots in 6 minutes, you simply have to move the decimal one place to the left, and we will be traveling 2 nautical miles. If we travel 1.8 miles in 6 minutes, move the decimal to the right, and we are traveling 18 knots. We will be constructing a basic navigation triangle. And the 3 legs of the triangle will be, the first leg is going to be our own ship's true course and true speed, or our true motion. This will be labeled E2R. The second leg of the triangle will be relative motion, or the relative motion line. And this is going to be labeled R2M. And the third leg of the triangle is going to be the contact's true course and true speed, or the contact's true motion, which is going to be labeled E2M. This is the radar transfer plotting sheet. This line would indicate the heading flasher of the radar, indicating that we are going due north. Along the left-hand side of the plotting sheet, there are 4 distance scales: 6 miles, 12 miles, 3 miles, and 24 miles. Along the right-hand side of the plotting scale, there is a distance scale in knots. We will not be using this scale. There are 4 information boxes along each corner of the radar plotting sheet. In this circle, you can put target 1, target A. You can record your first observation time to the contact, its bearing, and its distance or its range. You can record your second observation time to the contact, its bearing, and its distance. When you've completed the triangle, you can record the information you've gotten from that triangle: CPA, bearing of CPA, time to closest point of approach, and true course and true speed of the contact. It's important we use the correct range scale. So many people will scratch out the range scales that they're not going to be using and circle the range scale that they will be using. I mentioned we are going 20 knots in 6 minutes, so we are going to travel 2 nautical miles. We will put that in the center of the plotting sheet. E0 knots is going to be our maximum speed of 20 knots. If you have a hard time remembering E to R, if you look at the bottom of the plotting sheet, I've circled on ship, true course and speed, E to R. We get a contact on our radar. It's approximately 11 miles away at 045 degrees. Using your dividers or your compass, you would measure 11 miles on the 12-mile scale. Get your ruler, put a dot at 045 degrees at 11 miles away. We will label this R00. R stands for a reference. For a reference, we need a time and a place. The time is going to be 00 minutes on the clock. The place is going to be the range and bearing of the contact. Since we have 6 minutes before we have to plot this contact again, we might as well put one leg of the triangle into the plotting sheet. We're going to parallel this E to R to this E to R. Simply parallel E to R and put it into the plotting sheet. 0 knots heading north to 20 knots, 0 knots heading north to 20 knots. We have one leg of the triangle complete. Six minutes later, we obtain another range and bearing, plot that on the plotting sheet, and we're going to label this M06. Now we'll connect the dots between R00 and M06, and we're going to draw a relative motion line. From this relative motion line, we can find direction of relative motion, speed of relative motion, CPA and bearing of CPA, and time the closest point of approach. To find direction of relative motion with your ruler parallel to the middle of the plotting sheet and just read it off the edge of the plotting sheet. So direction of relative motion, or D or M, is going to be approximately 220 degrees. To find speed of relative motion, we can find this in 2 ways. One way is a regular time speed distance calculation. With your dividers or your compass, measure the distance between R00 and M06. This distance, 6 minutes, divided by 6 minutes, and we can find speed of relative motion, or SRM. Second way we can find speed of relative motion, with that distance between R00 and M06, take it over to the 12-mile scale. Looks like it's approximately 2.3 miles. The speed of relative motion is going to be 23 knots. The next thing we can obtain from this relative motion line is CPA, or closest point of approach. CPA is always going to be a right angle from the relative motion line, a 90-degree turn from the relative motion line to the middle. It looks like they're going to miss us approximately a little over 1 mile. Measure that distance, and you can find out exactly how far on the 12-mile range scale they will miss us by. From our coastal navigation training days, we learned that bearing is from us to something else. So bearing of CPA is going to be from us to CPA to just the tick mark along the edge of the radar plotting sheet. And it looks like the bearing of CPA is going to be approximately 135 degrees. So when this contact reaches CPA, you look at your bridge wing at approximately 135 degrees, a little over 1 mile away. This is where the contact will be. The last thing we can derive from this relative motion line is what time is CPA, or TCPA. There's two ways to do this. First is a time speed distance calculation. Measure between R00 and CPA. You have a distance. We've already calculated relative speed at 20 knots. So time to closest point of approach is going to be distance from R00 to CPA divided by our 23 knots relative speed, and that will give you time to closest point of approach. The second way to find time to closest point of approach is simply measuring with your dividers or your compass between R00 and M06 and simply walking it down the relative motion scale. We have M06, we have M12, M18, M24, M30, M36. You can eyeball approximately what time CPA will be, approximately 34 minutes. Then we can finish the triangle. We can finish the E to M of the triangle. E is 0 knots. It was the beginning of our true course and our true speed. E is going to be the beginning of the contact's true course and true speed. So to find the contact's true course, you're going to parallel E to M06 and just put a tick mark along the edge of the plotting sheet. The true course is 315 degrees. If you have a difficult time remembering what E and M is, at the bottom of the plotting sheet it says other ship, true course and true speed, E to M. To find the contact's true speed, measure between E and M06, take it over to the 12-mile scale. Looks like it's approximately 1.8 miles. The true speed of the contact is 18 knots. So this contact's true course and true speed is 315 degrees at 18 knots. Also from the E to M of the triangle, this is going to show the aspect of the vessel, which lights we will see on this vessel. This will invoke the steering and sailing rules. We are here on the radar. We will see a port light and mast or masthead lights on this contact. If this relative motion line is falling astern of us, if this relative motion line fell ahead of us, they would cross ahead of us. if R00 and M06, this relative motion line came right through the middle, we would have what is known as a constant bearing decreasing range, or CBDR. It would result in a collision. So what is this contact doing? So the relative motion is in this direction, the true course is in this direction. So what's going to happen, they're going to crab down this relative motion line. So at 12 minutes, you will still see a port light and masthead lights. 18 minutes, port light and masthead light. 24 minutes, port light and masthead lights. 30 minutes, port light and masthead lights. At CPA, you will see a port light and a starboard light and mast or masthead lights. And at 36 minutes, you will see a starboard light and mast or masthead lights. Additional objectives for course or speed changes. In this section, we will determine a new course to steer in order to maintain a required CPA, or 2, determine a new speed in order to maintain a required CPA. Therefore, we will need a couple additional labels. We're going to need an execution point. So when this contact tracks down the relative motion to the point we determine, a time or a place, we're going to execute our course change or speed change. This execution point is going to be labeled MX. To indicate a new course or new speed, we will label it R prime. Some people call it R1. That is acceptable. We've appraised that we're seeing a red light on this contact, and this is going to be a crossing situation. For this problem, we have a required 2-mile CPA we have to maintain around our vessel. We know this is a crossing situation, but she's taken our stern by a little over 1 mile. It's my obligation to open up the CPA. My obligation. So what we're going to do, we're going to alter course to starboard, and we're going to take that stern. So that's the plan. So when they get to MX, I've chosen 5 miles from us for my execution point. When they track down this relative motion line, they get to MX, I am going to alter course to starboard and find a new course so I can maintain a required CPA. There's a relative motion rule that if we alter course to starboard, it's going to make the contact look like they turned to starboard. So if I alter course, I'm going to change relative motion. So I'm going to draw a new relative motion line from MX to the tangent or the edge or the side of my required CPA. This is a new relative motion line. Then we're going to parallel this new relative motion line, MX to M06. Some instructors like me teach the candy M&Ms, M&M, MX to M06. You're going to parallel that new relative motion line to M06 and draw it out to starboard. E never moves since it's 0 knots. So we're going to stab it with our dividers or our compass, and we're going to swing R to starboard until it just touches this new relative motion line. And this will be labeled R prime. Some people label RC for revised course. That's acceptable. My original course was E to R, heading due north at 20 knots. My new course is going to be E to R prime. So we're going north, we change course, and our new course is E to R prime. Now we're going to parallel this E to R prime to the middle to find out what the new course is going to be. Approximately 042 degrees. So So when this contact tracks down this relative motion line, they get to my execution point, mx, I'm going to alter course to 042 degrees. If I turn to starboard, it's going to make them look like they turned to starboard. Then they're going to start tracking down this new relative motion line. This is where I monitor and revise my plot. So they should start tracking down this new relative motion line. If they start coming in here, just move over the starboard to open up the CPA. If they start moving out here, great, we opened up the CPA and maybe used up a little extra fuel. Eventually, you need to come back on your original course. Well, this is not on most Coast Guard examinations. When you would know you would come back on your original course would be a right angle from the new relative motion line to the center. So right about here, you would come back on your original course. If I didn't change course, I could change speed. Maybe I have shoal water over here or some vessels or obstructions that prevents me from altering course to starboard. So I could slow down or change speed. Course changes and speed changes are done exactly the same way. If I change course, I change relative motion. If I change speed, I change relative motion. So we still need that new relative motion line from mx to the tangent of our required CPA of 2 miles. M&Ms parallel mx to M06 and draw that new relative motion line out to our starboard side. E is 0 knots. R is our maximum speed. So wherever those two lines intersect, our true course and our true speed and that new relative motion line, you could slow down to that new speed and that contact will cross ahead of us by 2 miles. So you measure this distance from here to that where those two lines intersect, take it over the 12-mile scale and find out what speed you would need to reduce to so that contact will cross ahead and we maintain a required CPA of 2 miles. To review the course change, we need that new relative motion line from mx to our required CPA. M&Ms parallel mx to M06. Draw that new relative motion line out to our starboard side. We're going to stab E and swing R to starboard. And label that R prime or RC. Our old course was from E to R. Our new course is going to be from E to R prime. Parallel that to the center of the plotting sheet and you can find out what your new course. To review the new speed, if we change speed, we change relative motion. You still need that new relative motion line from mx to our required CPA. M&Ms parallel mx to M06. Draw that new relative motion line out to our starboard side. E is 0 knots. R is our maximum speed. So wherever these two lines converge, you can slow down to that speed right there. That's labeled R prime. Some people use RS for revised speed, and that's acceptable. To review our presentation, in this presentation we discussed and demonstrated 1. How to construct and label the radar plotting triangle. 2. From that triangle we determined direction and speed of relative motion, CPA and bearing of CPA, time to closest point of approach, contact's true course and true speed. Then we demonstrated how to obtain a new course in order to maintain a required CPA, or how to obtain a new speed in order to maintain a new CPA.